those who are not able to attend. And I'm going to share my screen. The outline for today, or kind of the plan, which is Monday, January the 30th of 2023, we're going to look at how to do the descriptive stats in Minitab, which will also include how to create a histogram. We'll also look at how to create a box plot in Minitab, but also I want you to be able to do a box plot by hand. I think that gives you a better sense of what is taking place. Then we will do the probability introduction and hopefully get into a discussion of contingency tables. The Module 2 exam is scheduled to open on Wednesday, which is February 1st. I am going to delay that because we are just a little bit behind, and I don't think we will have all of the content adequately covered for that exam, which covers all of Module 2 before really next week. So I've delayed it at least until February the 7th, which will be next Tuesday, which gets us at least 3 more class sessions. So just be aware that I've tried to go ahead and make the change in D2L. Also, you will have class participation 6, which is due on Sunday, February the 5th. All right, so let me kind of give you the lead in to the descriptive statistics. If we go back, and I'm going to go through this relatively quickly, to the question that we've been focusing on for the last lesson. Our question was, what is or what was the average age of a GHC student in fall 2023? We've said that you need to pose your question clearly and with as much detail as possible so that you can identify the variable, the population, the parameter, the sample, and the statistic. I want to point out one of the mistakes that I have consistently seen on the Module 1 exam is when students are trying to identify the variable. I want to stress again that the variable does not, should not include the measurement. The variable is the what. It is what you are looking for, what you are interested in learning about. There should not be any kind of measurement associated with it. For example, in this question that we've been looking at, what is or what was the average age of a GHC student in fall 2021? The variable is simply the age of a GHC student in fall 2021 in years. It is not, and it should not be, the average age. The word average is the measurement. The measurement is the parameter if it is related to the population, and it is the statistic if it is related to the sample. The variable itself is the what. Again, you need to think about what question would I walk up to you and ask. I would walk up to Rose Jane and I would say, Rose Jane, how old are you? Or I would walk up to Luciana and say, how old are you? I'm not saying, what is your average age? There's no such thing for an individual. Okay, so that seems to be a consistent error. So hopefully that little those comments there will help you not make that mistake again and again and again. So we've identified all of those pieces. We had our raw data. We created a grouped frequency distribution, remembering that our goal is to ultimately answer the question. We found that the category, or excuse me, the group frequency distribution didn't really give us the final answer. It began to give us an idea of what the average might be, and we noted from the frequency distribution that we thought the age was somewhere, the average age was somewhere, excuse me, between 15 and 24. We also looked at a stem and leaf plot, which is best for a small data set. We had 62 data values here. That might be too many. But the stem and leaves allow us to organize the data from low to high. It also allows us to retain the raw data. It also allowed us to kind of get a sense of how the data is distributed, that it appeared to be skewed to the right with most of the data values on the low end. We noted that the age that occurred the most was 18. The value in the middle was 21. And again, we feel like the average is probably somewhere between 18 and 29. I would say it's probably somewhere in this 18 to 21 range. But we still haven't actually answered the question. We then talked about the histogram, which we can create in Minitab, and we're going to do that in just a minute. I believe we looked at a little bit how to do that the other day. The primary thing with the histogram is we get a sense of the distribution or the shape. Excuse me, and there were 3 distributions we considered: skewed to the right, symmetric, and skewed to the left. Okay, here's where we created it in Minitab, and I'll walk back through that in just a minute. And we kind of estimated that since most of the data values were in this bar around 20, that we think the average is somewhere around 20. But even then, we still have not answered the question. We then talked about all the different kinds of descriptive statistics, our measures of center, the mean, the median, the mode, the measures of variation, range, variance, standard deviation. We also talked briefly about measures of position, which were our z-score, our percentiles, and more specifically the quartiles, which is the focus that we use, are the quartiles, because that helps us to determine ultimately if there are any outliers within the data set. And I kind of rough sketched a picture of that for you, because from the box plot you get the 5-number summary, which is your minimum, quartile 1, the median, quartile 3, and the maximum. And at that point we ran out of time. So I need to show you, and I'll review again, how to create the histogram in Minitab and show you how to do the descriptive statistics. Okay, so I'm going to make a note here. We're going to review how to create a histogram. Okay, I'm going to type here the clicks that you would use in Minitab to create the histogram. Okay, you have to have entered your data. Okay, you cannot do anything. You cannot create a histogram, a box plot, do anything in Minitab without the data. And for most of the things that you'll be doing this semester, you'll be given the data set like you were given in that problem, and you will have to use your fingers to type that in. Once you have the data in Minitab, then we can do lots of things with it. Now, the one downside is we don't really have the ability to save things. So you want to do every kind of as much as you can at one time once you have the data in there. So if I'm going to create a histogram, I would go to graph, because the histogram is a graph. I'm going to scroll until I find the option for a histogram, because when I choose graph, it gives me a drop-down menu of all the different graphs that we can create. We're going to do a one variable simple. So we're going to do one variable y. We're only using one variable. At this point, we're only talking about age, and we keep it as simple as possible for this course. And you do actually have to double click, if I'm not mistaken, when you make that selection. Okay, so we go graph, simple, double click. Then we have to select the variable. Okay, so let's say we're going to select the y variable. I use the options button and I want to click. You want to choose data labels. I think that's the option. I'll have to double check. Nope, we don't choose anything there. Sorry. That's on a bar graph. Okay, so I don't need to do this. We choose the y variable and then we click OK. And our histogram should appear. Okay, so let me pause there for a minute so you can write those things down. All right, so I'm going over to Minitab. I have already typed the data in this morning to save time during our discussion. So I have in column 1, in the lower half of my screen, the ages in years of GHC students in fall 21. I've typed the data in. I go to graph, histogram, one variable, one y variable, keeping it simple. I choose the variable that I need. I've only got one in the system right now on my spreadsheet. Select it. And I click OK. And my histogram appears in the upper part of the screen. Now, a couple of things that I pointed out to you the other day. You do need to make sure that your title is descriptive and detailed. To update your title, you select the graph by clicking on the graph, and then you use the triangle in the upper right hand corner to choose graph options. I'm going back over to Word to put those clicks in there. So you're going to add a descriptive title. So you select the graph by clicking in the area around the graph, and it should come up and you'll see kind of a black line around the graph. Use the triangle in the upper right corner to choose graph options to change title. And there's other things you can do there as well. Okay, you also can do that same process. Same process is used to copy the graph whenever you need to paste it into a Word document or whatever. So again, let me pause for a minute in case you're writing those things down. I've been posting these notes, so you should be able to copy them off or print them. Okay, so again, I have selected the graph. You notice the black lines that kind of outline the graph. Upper right-hand corner, I'm going to click on the triangle and choose graph options. And then I can change the title. I may put age in years of GHC students. And then I can use a subtitle and put fall 2021. Again, you want as many details when you're giving something the title. Any graph that you create, you should think about who, where, what, and when. Because you want someone to be able to come in and look at this graph and know exactly what information is on the graph. Once I've made the adjustments, I can close that window and I have my graph. While you're in Minitab, this graph, remember, is interactive. I can hover my mouse over the bars and it gives me information. This bar represents ages between 17 and a half and 22 and a half, and there were 39 values. The next bar is between 22 and a half and 27 and a half, and it had 9. So while you're in Minitab, you have this interactivity where you can hover over the bars. Now, once I copy it, I lose that interactivity. To copy it, again, you select it, use the triangle, and we choose copy, and I can take it into Word, Excel, PowerPoint, whatever, and paste it. Again, I notice one of the things you have to be able to do is determine the distribution of the histogram. And again, I notice in this particular problem that most of my data values appear to be on the low end, and they taper off as the ages go up. And because I have lots of values on the low end, which is on the left, we know that this distribution is skewed to the right. Again, thinking about an average, I still don't have the exact value, but again, I have a lot of values in this first bar, which was between 17 and a half and 22 and a half. So I might estimate or guess that the average age is somewhere between 17 and a half and 22 and a half. We used the midpoint the other day, which was 20. So we were estimating that we think it's 20, but we still haven't found the exact value yet. Now, Rose Jane, that was something you had specifically asked me about. So are you okay? Come on. I can't see the chat, so I'm having to assume you said yes. It's not letting me get. I don't understand. I tried to put the data on Minitab for the adjusted GPA and my frequency. Why are you putting your frequency? You should be using the raw data. I don't understand, Rose Jane. Okay. So you found where your mistake was. Okay. So let's talk about then how to calculate all of those descriptive statistics. I didn't get to cover that last week because we ran out of time. Minitab will calculate all of your descriptive statistics in a single command. Okay, it will do the mean, the median, the mode, the range, the standard deviation, the variance. It'll give you the quartiles. It'll give you the interquartile range, all of the statistics you need for the sample with one command. Now, you do not have to memorize the list of statistics that you have to calculate. If you look ahead to class participation 6, on the document, it tells you, I want you to calculate the sample size, the mean, the sample standard deviation, the sample variance, the minimum, first quartile, median, third quartile, maximum, mode, interquartile range, and range. Okay, so the list of all the things you need to calculate is on the class participation 6. Your homeworks related to this topic are matching. So you'll have the list of things, mean, sample size, all that kind of stuff on, I think they're on the left, and your options, your choices are on the right, and you match them. So again, the list is available. You don't have to memorize the list. Okay, so again, to do anything in Minitab, you have to have the data. So again, we've already entered the data. So I don't have to enter it again. I'm going to just keep using it. It's already there. Okay, so in Minitab, to get to the descriptive statistics that we need, we're going to go Stat, Basic Statistics, Display, Descriptive Statistics. Okay, then I got to check to see because I don't remember them. I just know the clicks. Display. Okay, then we're going to choose the variable. Okay, let me get you the clicks. Okay, so then you're going to choose the variable. And you're going to select the statistics button to choose all the statistics to be calculated. And then you'll click OK. And then you're going to click OK again, and you get all of the statistics. Minitab does all of the work. Guys, nobody in their right mind, to be quite honest, that does research in today's world does anything by hand. Okay, they use some form of technology, whether it's a computer, a software program like Minitab, whether it's a free website. Some people will still use Microsoft Excel, although Microsoft Excel was never intended to be used for statistical analysis. You can use a calculator, but nobody does it by hand. All right, so we're going over to Minitab. And again, I have already entered my data. It's already there. I don't have to retype it again. It's there. It's not gone away. Then I want to calculate my descriptive statistics. So I have Stat, Basic Statistics, Display Descriptive Statistics. I have to choose my variable. Again, I'm doing age. Then I'm going to use this widget button labeled Statistics. I'm going to click on it, and it gives me a display of all the things it will calculate from the list, either on my homework problems, on the test problems, on class participation 6. I'm going to choose the things I need. There are some things already selected that I need to deselect, but I need the mean, the standard deviation, the variance. First quartile, median, third quartile, interquartile range, mode, the minimum, the maximum, the range. I don't need non-missing and missing. I do need the total number of n. So again, I'm going to pause there for just a minute so you can make note of the things to check. Again, the list is available on the assignment, on the homework, on the test. You don't have to memorize it. Okay, so then I click OK. And I click OK again. And it displays all of those calculations at one time. So I could then, if I were doing my assignment, take this back over here to the Word document. And let me copy this table. So if this were my class participation 6 assignment, Minitab has calculated all of my statistics. I'm then going to record them. I'm going to write them down. So the first one says, what is the sample size? So my total count, okay, if you want to make a note, Minitab calls this total count, was 62. My mean was 24.73. The sample standard deviation was 9.53. The variance is 90.73. The minimum was 18. Quartile 1 is 18.75. The median is 21. Quartile 3 is 25.25. Maximum was 57. The mode, now be careful, the mode is out here at the end. Okay, and it really tells you two things. It tells me what value was the mode, and then it tells me how many times it occurred. So the mode was 18 and it occurred 15 times. So I have 18. Then I have the interquartile range, which it abbreviates IQR. Interquartile range is IQR. We talked about that the other day. It's 6.5. And then the range was 39. So again, Minitab is doing all of the calculations. And guys, there's no reason to miss those questions unless you've mistyped the data. So it is worth your time to double check, triple check that you did not enter the data incorrectly. Okay, so from Minitab, I get all of my statistics. I need the 5-number summary, which is the minimum, first quartile, median, third quartile, and maximum. That's my 5-number summary, and I need those values to help me create box plot. Now, Minitab will give us a box plot. It will draw it for us. But again, I think it helps you to maybe get a better understanding if you can draw it by hand. So I'm going to show you, first of all, how to do it by hand, and then I'll show you how to do it in Minitab. A box plot, just as a side note, can be displayed horizontally, or it can be displayed vertically. And it doesn't matter which way, which way you display it. I have a tendency when I draw it by hand to do it horizontally. I do know that Minitab draws it vertically. It's okay. You should get the same picture. So I'm going to sketch a box plot. When you do the box plot, it has to show the minimum and the maximum. Our minimum was 18. Our maximum was 57. So I could start with those values. I could start with a low of 18, and I've got to work my way up to 57. And I need to pick a scale, so maybe I'm going to count by threes. So I'd have 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, and 57. Okay, so I have it drawn a little bit too far. Oops. Okay, so I've drawn my number line, and again, the number line has to encompass the minimum and the maximum. Now I could have started at 15 and gone to 60. It's okay, but you have to at least encompass the minimum and the maximum. So I know that my minimum is 18. So slightly above the number line, I'm going to draw a little dot at 18. That's my minimum. Quartile 1 was 18.75. So just a little bit next door to that's going to be Q1, which is 18.75. My median was 21. So I'm going to put a dot at 21. That's the median. 25.25 was Q3. And then 57 was my maximum. To get my box, I draw the box around Q1 to Q3. And then I draw a line from Q3 out to the maximum and a line from Q1 to the minimum. Again, notice that the box is on the lower end. It's on the left-hand side. So even the box plot demonstrates or shows that we have a distribution which is skewed to the right. Okay, so this box plot, just like our histogram, is skewed to the right because the box is on the lower end. Now, I'm going to show you how to create that same box plot in Minitab. Again, remember the deal with the box plot, couple of things, is that between the minimum and Q1 is 25% of the data. Between Q1 and the median, you have 25% of the data. Between the median and Q3, you have 25% of the data. So in this case, we would say 25% of the GHC students in fall 2021 are younger. Idea that it's below 18.75 years old, because 18.75 was Q1. So 25% of the students were younger than 18.75. If we look at Q2, you have 50%. So 50% of the GHC students in fall 2021 are younger or below 21 years old. 21 years old is our median, which is the same thing as Q2. And then you have your Q3. Q3, you have 25, 25, and 25. So we would say 75% of the GHC students in fall 2021 are younger or below 25.25 years old. That's Q3. So again, it kind of just helps you to see how the data is divided up into groups. We basically create 4 groups with 25% each. Now, I'm going to show you how to create a box plot in Minitab. So I'm going to come down here and I'm going to put box plot in Minitab. And I'm going to give you the keystrokes. Again, a box plot is a graph. So we would go to graph and then choose box plot. I believe we're going to keep it simple, but let me double check. One variable y, simple. Okay, so then you're going to go one variable y. We're going to keep it simple. And you have to double click. Then you're going to select the y variable. And make sure. I don't think we need to do options. Nope. So then you click OK. And your graph should appear. Again, even with the box plot, you want to have a descriptive title, and you do that the same way that we did before with the histogram. That process does not change. I'm pausing for you to write it down in case that's what you're doing. All right, now we're going to do it. Again, my data for this question that we're working on is already entered into Minitab. I do not have to enter it again. We go to graph, box plot, one variable y, keep it simple, double click, choose the y variable, and click OK. And you see your box plot on the screen. Now, the box plot that you see here looks quite different from the one I drew by hand, but all of the information is there. One of the things that you see on the box plot here in Minitab are these stars. One of the things that the box plot does is it will visually show you the outliers. In Minitab, when it creates the box plot, any value that is an outlier is represented by an asterisk or a star. And it will even identify those for you if you hover your mouse over it. So in this case, the age of 57, 54, 50, 47, 46, 39, 38, and 37 are considered outliers. So this particular data set has 8 outliers because there are 8 stars. Again, you have a little bit of interactivity because if I hover my mouse over the blue box, it shows that Q1 is the 18.75. The Q1, and I'll kind of copy this over in just a minute and make some notes here for you. But Q1 is this lower bar of the rectangle. Q2, or the median, is the one in the middle, and Q3 is at the top. The one difference is my whisker doesn't go out all the way to the last value. It stops at the point where I begin to have outliers. And we'll talk about how to determine that value in just a minute. Now, to change the title, again, to make it descriptive and detailed, I select the graph. Notice the black frame around it. Click on the triangle, go to graph options. So I can put ages of GHC students. I probably should say in years of GHC students. And again, I can add a subtitle for fall 2021. Again, remember, you want to have who, where, what, and when in your title. You want it to be descriptive. Once you've made that descriptive title, you can close the window. Using that same process, select and copy. You can then copy it into Excel, into Word, or so forth. So again, just for emphasis sake, to kind of help you see, this little bar comes down, in this case, to the minimum. The lower part of the rectangle is Q1. The line in the middle of the rectangle is your median, which is the same as Q2. And then the third one there is Q3. Now again, one of the differences with the box plot for Minitab is that my other little line, or they'll call it a whisker, doesn't go all the way out to the maximum. This is my maximum. These stars, remember, are my outliers. So this particular data set has 8 outliers. Again, notice how that the box is on the lower end because the box is on the lower end. Again, I can see that my distribution is skewed to the right. And I can verify that. Remember, we have a method for verifying for sure, beyond a shadow of a doubt, that this distribution is skewed to the right. I mentioned to you probably several days ago in a lesson that we can compare the mean, the median, and the mode. For skewed to the right, the median, the mode is the smallest, then the median, then the mean. So if I look at my measures of center, they should line up. Mode is the smallest, median in the middle, and then the mean is the highest. So if I go back and look at my descriptive statistics, my mode was 18, the median was 21, and the mean was 24.73. So my mode was 18, the median was 21, and the mean was 24.73. And if you'll notice, 18 is less than 21, and 21 is less than 24.73. So I can verify, confirm, prove beyond a shadow of a doubt that my distribution is skewed to the right. So I have verified the distribution is skewed to the right. Now, I will tell you that sometimes the mode, especially if you have more than one mode, might do something funky. If it's doing something funky, then you focus primarily on the median and the mean. But I now can verify beyond a shadow of a doubt that my distribution is skewed to the right. I also now really and truly have enough information to answer the problem, because we calculated the sample mean. And the sample mean for this data set was 24.73. So that is likely the average age of a GHC student in fall 2021, which does seem high when you think about all of the other graphs and tables that we've looked at. It's being influenced or affected by those 8 outliers. The last thing I want to mention here in relationship to descriptive statistics is that idea of the outliers. We saw them visually So visually you can see them on the box plot from Minitab. But how could we, if we didn't have, that box plot to look at? Or how can we confirm, again, verify that those values are really outliers? We have a formula, or if you want to call it an algebraic method for determining where the outliers are. How did Minitab know to kind of stop that whisker at 35? It's because there's a formula. The formula says any data value less than Q1 minus 1.5 times the interquartile range, or any data value greater than Q3 plus 1.5 times the IQR. You have to consider that there could be outliers on the lower end or the higher end. That's why there's two formulas or two pieces here. So if we look at our numbers for this particular problem, and again, we have all of those values because we get those from Minitab. If we think about what is the value for Q1 minus 1.5 times the IQR. So we have 18.75, that's Q1, minus 1.5. Let's see, let me go back and get the IQR. Now, IQR was 6.5. Now, guys, it's important that you follow order of operations here. In order of operations, you would multiply 1.5 times 6.5 first, which gives me 9.75. So 18.75 minus 9.75 is 9. So if I have any data value less than 9, it's an outlier. Well, guys, think about it. We didn't have any students that were younger than 9. So I don't have any on that end. But then on the upper end, I have Q3 plus 1.5 times the IQR. Q3 was 25.25 plus 1.5 times our IQR, which is 6.5. Again, you have to do the multiplication first. 1.5 times 6.5 is 9.75. So 25.25 plus 9.75 gives me 35. So any data value greater than 35. So that's why when you look at this box plot and hover over the blue rectangle, it tells you that the whisker is from 18, which is your minimum, to 35. The 35 is the limit of where your outliers would begin. Let's look at it. If I look at it on the histogram or on the box plot that I drew, we don't really need to go beyond the 18 because that was our lowest value. But we would have, it's almost like you've got a fence post here at 35. Anything below 35 is good. Anything above 35 is an outlier. Again, those would be data values that, for whatever reason, just don't seem to fit with the rest of the data. Now, I wouldn't normally draw that on a box plot if I'm drawing it by hand, but again, I want to try to help you see what is taking place. Okay, let me make sure you understand. For class participation 6, you're going to calculate the descriptive statistics for the variable based on the value that your last name begins with. It's not ends, it begins. I'll have to fix that. Okay, so you're going to do the calculation. So like Rose Jane is going to continue to use the adjusted GPA because her last name starts with A. And so she's going to calculate the descriptive statistics for the adjusted GPA. Then using the 5-number summary, she's going to draw by hand the box plot. Now, if you need to, when you draw the box plot, draw it paper and pencil, take a picture of it, and then you can post it up to the assignment page. Then you have to verify that it is either skewed left, symmetric, or skewed right. I just showed you how to do that. To verify that it's skewed to the left, skewed to the right, or symmetric, you have to physically show me with the numbers the relationship between the mean, the median, and the mode. Then the last question is asked, do you have any outliers? And you're either going to say yes or no. So you could look at the box plot in Minitab to determine whether there are. Then it says verify your response algebraically. So you then have to show me the numbers. That an outlier for our data set would be anything that is less than 9 or anything that is greater than 35, which we saw visually on the box plot. Now, I'm not going to spend class time today for you guys to work on class participation 6 for a couple of reasons. One, last week when I let you work on it, everybody left. And I spent the last hour and a half talking to myself. Two is we're running a little bit behind, so I'm going to have you do it outside this time that we have for discussion or explanations. But do you have questions related to this content that I can answer for you before we move on? Okay. All right. Let's take a quick 5-minute break so you can get a drink of water, go to the restroom, whatever you might need to do. 5 minutes, and we're going to come back and we're going to get into the topic of probability. Okay, that's the next topic or the next lesson. Okay, so take a quick 5 minutes. I'm going to step away from the computer for a minute, and I'm going to pause the recording. Okay, ladies, did you think of any questions that you may have before we move on? Okay, I have restarted the recording. I'm going to share my screen, and we're going to use the PowerPoint related to this topic of probability. It may seem odd to have this discussion kind of in the middle of Module 2. We've been talking a lot about statistics. We haven't really talked a lot about probability, but the deal is probability actually creates the foundation for all of the things that we do in statistics. And so we need to talk about what is probability, how is it useful, to you, and then how is it calculated, and some of the basic rules and guidelines. Most people probably have a basic understanding of probability, and they tend to relate it to maybe the weather, because they'll say, you know, there's a 70% chance of rain today, or there's a 20% chance of rain today, or to maybe gambling, winning the lottery, that kind of thing. But probability is useful to you because basically, from the time you get up in the morning until the time you go to bed, we as individuals make decisions that are governed in part by chance or probability. You know, things like, should I carry an umbrella today? You know, if I hear the weatherman say there's a 20% chance of rain today, I'm probably not going to carry an umbrella. But if on the other hand, he says there's a 90% chance of rain today, I'm probably going to make a decision to carry my umbrella because I don't want to get wet when I'm coming out of the office, or, you know, going in between buildings or whatever. Should I accept that new job? We think about, oftentimes we kind of weigh the pros and cons of accepting a new job. You know, will you like it? Will you not like it? Will you like your boss? Will you like the people you know? So you may not realize it, but as you are weighing those pros and cons, you're actually thinking about chance or probability. Oh, it's hung up. Hold on a second, guys. It's got hung up on me. It likes to do that occasionally, remember. And then the third question there is, do I have enough gas to get to school this morning, or should I stop and put gas, you know, in the vehicle and risk being late? Again, so we make decisions really every day. We don't necessarily go around thinking about the fact that we're relying on probability or chance, but we are. So everything we do pretty much on a regular basis or every day in life, at work, at play, or whatever, is based on probability. Probability in general is the likelihood or the chance that a particular event is going to occur. You know, what's the chance that the Philadelphia Eagles are going to win the Super Bowl in 2 weeks? Or what's the chance that the Kansas City Chiefs are going to win the Super Bowl in a couple of weeks? What's the chance of running out of gas on the way to work? You know, what's the chance of winning the lottery? You know, what's the chance of getting, you know, 3 cherries when you pull that arm on a slot machine? What's the chance of getting 21 if you're playing, you know, cards or blackjack? So, and again, most people associate probabilities with things like the lotteries, slot machines, maybe even sports betting. In theory, okay, kind of behind the scenes, when we don't necessarily think about it or see it, probability is the underlying foundation on which inferential statistics is built. We use what we've learned about the sample so that we can then apply it to the population. We take what we learn about the small group and infer through inferential statistics back to the population. And guys, companies, like when they're setting insurance rates for life insurance, car insurance, any kind of investment, weather forecasting, they utilize probabilities. They also utilize their knowledge of, what has happened with that particular stock, that particular investment, over the past few months, over the past few years, over the past 10 to 20 years. Same thing with weather forecasting. They think about, the previous weather patterns, what has happened in the past, what are the current patterns, and that sort of thing. So everything kind of comes together and creates that foundation. So everything we do statistically is based on probability. So that's why we're going to talk about probability in this course, because we got to kind of have that foundation as we begin to think about that process of transitioning from a discussion of the descriptive statistics to a discussion of inferential statistics. So there are 4 basic probability rules. Okay, and I want to talk about those 4 rules, and then also talk a little bit about how we can calculate, or how we calculate probabilities. Again, most people have a basic understanding, but I don't want to make too big of an assumption. The first rule says the probability of any event is a number, fraction or decimal, between and including 0 and 1. Okay, so all probabilities have a value between 0 and 1, meaning they are never negative, and it's never going to be bigger than 1. Sometimes you hear us saying about, oh man, that guy, he gave 110%. Statistically, there is no way to give 110%. The maximum is 100%. Okay, so all probabilities are between 0 and 1. Okay, so I'm going to kind of draw a picture here as we go, as we're thinking about probability. So if you're thinking about it again, if you think about it like a number line when you're thinking about probabilities, okay, the lowest value is going to be 0, and the highest value is going to be 1, and then you can have any possible value in between. Again, and it says this on the PowerPoint, but again, probabilities are never negative, and it's never greater than 1 or 100%. Okay, and then I give you some examples there of different scenarios of what probabilities could be. Okay, so let's go back over to my paper and kind of do it this way. Okay, the probability of 0 means that the event is impossible. Probability of 0 means an event is impossible. No way, no how is that event going to occur. Regardless of what you do, that event will never, ever occur. Okay, so for example, thinking about it being impossible, if I ask you what's the probability that you would roll a 7 on a die? Well, a die is a 6-sided cube that is numbered 1, 2, 3, 4, 5, 6. So there is no way that you would ever roll a 7 on a single die. So the probability is 0. Probability that Thanksgiving is on a Sunday. At least in the United States. Okay, there again, if you know anything about the calendar within the United States, Thanksgiving is always on a Thursday. There's no way, no how it would ever be on a Sunday unless the Congress changed the law. So there's no way that Thanksgiving would ever be on a Sunday. So my probability would be 0. So probability of 0 means that the event is impossible. No way, no how is that particular event going to occur, no matter what you do. On the other extreme, probability of 1 means the event is certain. The event is going to occur regardless of what you do. Probability of 1 or 100% means the event is going to occur regardless of what you do to try to stop it. So for example, let's say, what's the probability we roll a number less than 7 on a die? Okay, well, all of the numbers on a die are less than 7. So regardless of whether I roll a 1, a 2, a 3, a 4, a 5, or a 6, I'm going to have a number less than 7. So that event is going to happen regardless. So the probability is 1 or 100%. Probability that Easter is on Sunday in the United States. Now, there again, if you know anything about the calendar within the United States, Easter is always observed on a Sunday. So regardless of what I try to do, this event is going to occur. Now, thinking about the idea that it could be any value between 0 meaning impossible, 1 meaning it's certain. If you think about, halfway, that would be 1/2, or we could say 0.5 or 50%. Okay, so that's kind of the halfway mark. That's, where we think about having that 50-50. But I can be any value, any decimal, any fraction in between 0 and 1. Typically, when you're thinking about the measurement of probability, if you'll think about it somewhat like a thermometer, if you're at 0, of course, it's impossible. So if you're somewhere close to 0, that particular event is unlikely. But as you move and get higher and closer to 1, the event becomes likely. And so we can talk about, or you'll also see words like it's very unusual or usual. And you can think about that kind of on a graduated scale. The closer you are to 0, the more unusual, the more unlikely. But the closer I get to, say, 1, then it becomes more likely. So typically anything, the 50% mark is kind of the delineation. We usually, anything less than 50% we say is unlikely. Anything above 50% we think about as being likely. But again, we can have that more or less likely. You can have the more or less in there. So again, thinking about that, let me put some words in here for you. So, this is going to be less and we think about more, less, more. And again, the 50% mark is the delineation. So you would have less likely, or more likely, less unlikely, more unlikely, or less unusual, more unusual. Okay, actually I have this backwards. Let me fix this side for you. Got this side backwards because of its being low value. This would be very unlikely if it's close to 0, so that's more unlikely, and this would be less unlikely. Okay, the last rule, and let me go over here to the PowerPoint for it. The last rule says that the sum of the probabilities of all the outcomes in the sample space is 1. So basically what that's saying is if you consider all the things that could happen and then total the probability of each thing, it should total to 1. Because remember, 1 means something's going to happen. So for example, if my thing that I'm doing is flipping a coin, when I flip a coin, I can either get a head or a tail. So I have a 50% chance of a head, a 50% chance of a tail. Those are the only two things that can happen when I flip a coin. And so if I consider probability of a head plus a probability of a tail, 50% plus 50% is 1 whole, or 100%. Because something's going to happen when I flip that coin. Similarly, if you think about rolling a die, and it looks like I've got some numbers missing here. Okay, if you roll a die, you have a 1 in 6 chance of rolling a 1, a 1 in 6 chance of a 2, a 1 in 6 chance of a 3, a 1 in 6 chance of a 4. It looks like some of my numbers are missing. Probability of 5 is 1 out of 6, and a probability of rolling a 6 would also be 1 out of 6. That's the 6 things that can happen when you roll that 6-sided cube. Well, if you add all of those up, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, you get 6 over 6, or 1, or 100%. Okay, we're going to be utilizing these 4 rules as we go throughout our discussion of probabilities. So again, it's important for you to remember that all probabilities are between 0 and 1. 0 means the event is impossible. No way, no how is it happening. Probability of 1 means it's gonna happen. And last is that if you consider all the things for a particular event, the probabilities have to total to 1. Now, probabilities, as you've kind of seen in this presentation, probabilities can be written as fractions, decimals, or percents. Okay, so probabilities can be written as a fraction, a decimal, or a percentage. And you may say, well, Ms. Ralston, is one way better than another? And I would tell you not necessarily. Sometimes perhaps it's going to depend upon your audience. Again, think about the weather person or the weatherman or the weatherwoman. They typically state things in terms of a percentage, like there's a 20% chance of rain today, or there's a 70% chance of snow. So they talk in terms of percentages, again, because most people can understand or have an understanding of percentages. Most people are not well versed at fractions, so we might tend to avoid fractions. You know, decimals are kind of the in between. So sometimes it depends on your audience. Sometimes it also depends on the manner in which you determine that probability. Because for some events, the probability is determined theoretically. Okay. And in other cases, it's determined what we call empirically by an experiment. There, an example of where you might determine the probability theoretically goes back to the idea of flipping the coin. And again, oftentimes you would see that written as a fraction because it's going to be the number of ways to get, say, a head. So if we were thinking about flipping a head, it's how many ways you can get a head, which is 1 over the total number of things that could happen. It's almost like a frequency or a relative frequency. You're looking at the number of times or the number of ways that a particular event can occur. So there's one way to get a tail, and there's a total of 2 things. So theoretically, if you want to think about it, connects back to, for probability, connects back to the idea of relative frequency. It's the number of times that the event could occur, or how many ways the event can occur over the total. Empirical is more by an experiment where you have collected data. You know, what's the probability that I'm going to select someone with blue eyes based on the data that I have collected? Or even what's the probability I'm going to select someone between 15 and 19? Okay, so the empirical is more where you've done an experiment. This is probably the method you see a lot in research because you're basing it on the data collected. And it could change. I could collect a sample and get one value. Rose Jane could collect a second sample, a total different sample, and get a different value. And then Luciana could choose even a third sample and get a different answer. So the empirical probability sometimes will change. Now, ideally, there's consistency between the 3 different samples that we each select, but it might not be. It just depends. Okay, so just to kind of get some basic probabilities, we're going to look at some examples in a few minutes, and I'll show you how to do just a basic probability. But we're also going to look at probabilities that maybe involve and or. Okay, so hopefully that's not a lot of new information. One of the ways that we often display data when we collect the data for our study is we can use what's called a contingency table, or it's sometimes referred to as a two-way table. Okay, so we're going to talk a little bit about what is a contingency table and then how do we use it, and then we're going to use them to calculate the probability of some events. But this is a great way, a contingency table is a great way to organize your data when you've collected it. Okay, so a contingency table is a special type of a frequency distribution table. Okay, it's a special type of frequency distribution table. We've already looked at a categorical frequency distribution, and we've looked at a grouped frequency distribution. The contingency table is a special type of that, and it involves 2 variables that can be represented at the same time, and specifically it's 2 qualitative variables. So it allows us to look at two variables at the same time. Maybe we want to look at gender and eye color, or we want to look at maybe gender and pathway. Okay, but a contingency table allows you to represent or compare two qualitative variables at the same time. Again, I've stressed you have the relationship between two qualitative variables. One variable is represented on the rows of the table, and the other is represented on the columns of the table. So I want to kind of show you a setup. So who uses, or when is a contingency table used? Again, you'll see these used a lot in any kind of survey research. Maybe they're looking at gender as one of their characteristics, or age categories. You'll see it in business intelligence, maybe related to marketing, or do you have more men or women buying a certain product or a certain brand? Engineering and scientific research. For us, we're going to use it in probability theory and in Stat 2401. If any of you are going to take that course, which is the second one that meets the second 8 weeks of the semester, we focus on chi-square, test of independence, and test of homogeneity, and we do talk about and use the contingency tables then as well. Okay, so this is kind of a setup of a contingency table. So if we were looking at, in this particular case, we have gender as our row variable. Okay, that's our row variable. And we have political affiliation as the column. So again, you have two qualitative. So when you're talking qualitative, you're talking words or phrases. Okay, so your column variable here is your political affiliation. You also have columns that will allow you to do the total for the rows as well as the total for the columns. And in the lower right corner, this last box should be your grand total, and your grand total should always equal your sample size. Now, let's think about kind of how to read this. For example, if we don't have any numbers in here, but if we had numbers, okay, let me change colors here. Okay, if we were looking at this particular cell or this particular block on the table, notice that that's on the row for male and the column for Republican. So this would represent the number of males who are Republicans, or you could say it the other way, it's the number of Republicans who are males. But where the two come together, where your column and row meet, you have both characteristics. So that's the number of males who are Republicans. If we looked at, say, let's see if I can change colors again. If I went to this block, okay, if I look in this block, I'm now in the female row and the independent. So this would be the number of independents who are female. Again, the order of the words, I could say the number of females who are independents. The order of the words doesn't necessarily matter. But you need to realize where the two intersect is you have both characteristics. Questions? Because we're going to use the contingency table here in just a minute. Okay, so then on the next two slides, I have some examples of using a contingency table. And so I took these examples and pasted them into our Word document so that we could take a look at them. And so I'm going to bring them up here. Me try to delete all the extra pages so you guys don't have to print all the blank pages that I have. Takes me just a minute. Oops. Got something going on there. I don't want you to have to print all the blank pages, so see if I can get rid of it. Okay, so here's our question. Ooh, mercy. Okay. We're almost there. So here's the question. The question says, a pizza delivery company classifies its customers by gender and location of their residence. The research department has gathered data from a random sample of 1,585 customers. So they tell us that my sample size is 1,585 customers. Okay. That's the same as if I had the sample size for a data set. And so they have organized that information into a contingency table. They have the residence on the rows and the gender on the columns. Now, one thing they haven't done here is they didn't total these out for me. So that's where I may want to have a calculator so that I can total the values together. So I'm going to total the rows first. So for apartment, I would have 102 plus 115. So there are a total of 217 people that live in an apartment. 244 plus 157, that's 401 who live in a dorm. 63 plus 240, 303 who live with parents. 169 plus 200 is 369 that live in a sorority or fraternity house. And then 171 plus 124, which is 295, that live others and somewhere else. All right, and then you have, I need to do the columns. So I'm going to do the males. 102 plus 244 plus 63 plus 169 plus 171. There were 749 males. Then I do the females. 115 plus 157 plus 240 plus 200 plus 124 is 836. Now remember, this corner should total to my sample size, which is 1,585. So if I do 749 plus 836, I'm good there. I've got 1585. I'm going to double check myself, make sure I didn't misadd somewhere. So I'm going to do 217 plus 401 plus 303 plus 369 plus 295. Again, it totals, my column totals to 1585. So I've double checked, I didn't misadd anything. All right, then I'm going to use that table to answer the question. Okay, the first question says, what is the probability that the customer is female? So I'm going to select a customer, and I want to know the probability that it's a female. Okay, so we want the probability of a female. And again, I'm going to write these steps out so that you'll have them. We need to know the number of females in the study divided by the total number of customers. Now, I anticipate somewhere along the way you learned a little bit about probability, okay? But I'm trying not to make too many assumptions, okay? So just to do a straight, flat out probability question, for probability that it's a female, I have to consider how many were female out of the total number of customers. So if I go back to this table and I look at the column for females, there were a total of 836 females out of a total of 1,585 customers. Usually you're asked to write that as a decimal rounded to 3 places. So if I do 836, the top number, divided by 1585, I have approximately 0.52744. Now, if I'm going to round that to 3 decimal places, some of you have trouble rounding. The third decimal place is a 7. Next door is the 4. If it's 4 or less, you leave it alone. 5 or higher, you round up. So I would leave this one alone. It's going to be 0.527. Now, if I multiply that by 100%, it would be 52.7%. The answer you're usually asked for on the test or your homework is the decimal form. But at this point, we could say approximately 52.7% of the customers for this pizza delivery place are females. Okay, let me write these numbers down. All right, let me see if I can copy this. Okay, let's move to the next question. I'm going to have to make some space, so hold on. Okay, the next question is, what is the probability that a customer lives in an apartment? So you have the same contingency table. Okay, I just copied and pasted it. Okay, I have the same contingency table. And let me copy it again. And now I'm focusing on the fact that they live in an apartment. Okay, so we want to know the probability that the customer lives in an apartment. So again, you're going to look at the number in an apartment in relationship to the total number of customers. So if I look at my table and I go up to apartment, I can see there were 217 customers who lived in an apartment out of the 1,585 customers. Again, I'm going to convert that to a decimal. It's the numerator, 217, the top number, divided by 1585, which is the bottom number, and we get approximately 0.13698, so forth. Again, you are asked to round to 3 decimal places. The third decimal place is a 6. Next door is a 9. 9 is bigger than 5, so it's going to bump it up. So this would become 0.137. Or again, as a percentage, is 13.7% multiplied by 100. So we can determine that 13.7% of the customers live in an apartment. If you have questions, you need to stop me or raise your hand so I can, whoops. Well, fiddlesticks. Okay, let me get the table again. So I already have the numbers on there. All right, so I've got my table again. And the question is, what is the probability that the customer is a male who lives in the dorm? Okay, this is kind of a special case. It's not really a special case, but you have 2 conditions here. Okay, this is like an and statement because it's asking me what's the probability that the customer is male and lives in the dorm. So when I'm thinking about this, I have to make sure that I count just the ones who are male and live in the dorm. So again, you want the number of males in the dorm, and we're still going to compare that to the total number of customers. Okay, so this is an and. Okay, statistically, or when you're thinking about probability theory and you're thinking about this idea of and is the overlap. Okay, it's the overlap or the intersection. It's where the 2 conditions meet. Okay, it's the intersection. So if I were looking at this, okay, I'm going to look at males, and at the same time, I'm going to look at dorm. and I'm looking for the intersection. Whoops, I don't want to do black. Sorry. I'm looking for that intersection, which is this piece right here where the two colors overlap. I'm looking for males and dorm. They have to have both conditions. So there are 244. Okay, that's the overlap or the intersection. So there are 244 males who live in the dorm out of the 1585. Okay, so with and, you're looking for the overlap. And sometimes it doesn't have the word and in there, but it's implied. Man who lives in the dorm. Female who lives in an apartment. Okay, so it may not necessarily have the word and in there, but it's implied. So again, to convert it to decimals, 244, top number divided by 1585, the bottom number, we get 0.153943, so forth. Again, you are asked to round to 3 decimal places. There is a 3 in the third decimal place. Next door is a 9. 9 is going to bump it. So it becomes 0.154, or as a percentage, 15.4%. So about 15.4% of the customers are males who live in the dorm. Okay, let me get the graph again. Okay, for the next question, it's an or. Let me put this number back in there, 217. Okay, the next question says, what is the probability that the customer is female or lives with both parents? Okay. Again, in the world of statistics, the world of probability, the or that we use in mathematics is quite different from an or that is used in English. Okay, in statistics, we use what is called an excuse me. I'm saying it wrong. What we call an exclusive or, meaning I can have just female, just parents, but not both. I'm sorry, I'm saying that wrong. It's an inclusive because it could be both. Okay, so we use an inclusive or, meaning it could be just the female, just the parents, or it could be both at the same time. But you have to be careful when you're looking at this contingency table, because if you're not, you could double count. You have to be very, very careful. Okay, you have to avoid that you don't double count something. And let me show you what I mean. Okay, so in this case, when we think about or, we got to consider the probability that they're female, or, and it means to add, the probability that they live with their parents. Okay, but then we have to be careful because we don't want to double count. We have to subtract off the double count. So let's look at the table. If we put in our little our kind of highlight what we want. Okay, we want females, so this is females, so I have a total of 836 females. Or we want them to live with their parents, so we had 306. But here's the problem, guys. This 240, this 240 I've already counted as females. Those are your females who live with parents. I've already counted them. I don't want to count them a second time because that's going to screw my numbers up. So I have to be careful that I don't double count. So we had 836 females plus 303 who live with their parents, but I double counted 240 of them. And that's over my grand total of 1585. You have to be careful when you have the or, because you don't want to double count. So if I have 836 females plus the 303 who live with their parents, but I double counted the 240, so I'm going to subtract those off, I have 899. So 899 divided by my total of 1585 gives me the decimal 0.567192, so forth. Again, we're rounding to 3 decimal places. The 7 is in the third place. 1 is next door. It doesn't affect it. So it's 0.567 or 56.7%. So 56.7% of the customers are female or they live with their parents. That's usually the one that sometimes students struggle with. Okay, because that or gives them fits, because you have to be careful that you don't double count. Okay, that you don't double count. All right, then we've got one more. And let me copy the graph one more time. And it may help you guys. I'm copying and pasting, but even if you just rough sketch it out and do the highlights and things like I'm doing, that may help you when you are working through these problems. Okay, may help you when you're working through these problems. Now this last one is a little bit different. Usually the or and this one right here are the two that give students the fits most of the time. Okay, so this question says, given that, let me get down here, given that given that the customer is female, what is the probability the customer lives in a sorority or a fraternity house? Okay, this phrase, anytime you see that phrase, given that, that is what we call a conditional probability. They're giving you some sort of condition. In this case, the condition is that we know the customer is female. We know that we know that we know the customer is female, which means in this scenario, I do not care at all about the males. I don't even care about the totals. All I care about are the females because it tells me that my customer is a female. I do not care about anything else, only the females. And I'm interested, so I want, this one's a little bit different, the probability that they live in a sorority or fraternity house. Given that, that's the symbol for given that they're female. We're going to do the number in a sorority or fraternity house, but we divide only by the number of females. We are not dividing by the total this time because we know that we know that we know we got a female. So I don't have to worry about the males or anybody else. So if I look at my table for sorority and fraternity house, there are 200 females that live in a sorority or fraternity house out of the 836 females. Again, I'm not worried about the males, so I can exclude them because I know that I got a female. So 200 divided by 836 is 0.239234. Again, you're rounding to 3 places. The 9 is in the 3rd place. Next door is a 2. It doesn't change it, so this is 0.239 or 23.9%. Questions? I didn't bring the other example into the Word document, but we can still look at it here on this PowerPoint to try to give you some additional examples. It says a student is interested in whether there is a relationship between gender and major at her college. She randomly sampled some men and women on her campus and asked them if their major was part of the natural sciences, social sciences, or humanities. Her results appear in the table below. Now notice on this contingency table, again, they did the totals for you. So you have your men or women, the gender is on the rows, the major is on the columns, and you have the totals, and it appears your grand total or your sample size was 57. Okay, so I'm going to skip down to the 4th question here to start with. It says, what is the probability that the student is male? Probability the student is male. So I'm only interested in male students. So I'm going to count the number of male over the sample size. So if I look at my table, males or men, there were 23 out of the 57. Converting that to a decimal, 23 divided by 57 is 0.403508. Again, watch your rounding. 3 places. You got a 5 next door, so it bumps it up. It's 0.404. Working my way up backwards, says what is the probability that the student has a major in the natural sciences? Okay, so again, we're only interested in one thing here. We're only interested in the natural sciences, and we're going to compare that to the sample size. Okay, so for natural sciences, I had a total of 21 students out of 57. So 21 divided by 57, 21 goes in the calculator first. 0.368421. Again, rounding to 3 places. The 8 is in the 3rd place. 4 is next door. It's 0.368. The next question up, notice it says given. Okay, so we have a given that. And it says, what is the probability that a student has a major in the humanities given that the student is male? So in this scenario, I know that I've selected a male. So I'm not worried about all of the other students. I'm only worried about the males, and I want to know if they're a humanities major. So the number of, I'm going to ignore the women. I'm going to ignore the total. Okay, so there were 4 men out of 23 that were humanities majors. Again, because I know that I have a male, I'm going to ignore the women. I'm going to ignore the total. I'm only focusing on the men, and specifically those who were humanity majors. So it's 4 divided by 23. I get 0.173913. Rounding, the 3rd place is a 3. There is a 9 next door, which bumps it. So it's 0.174. The last example here says probability the student is a female with a major in social sciences. Female with a major in social sciences. This is an and. Okay, another way to think about the with is an and. So female and major in social sciences. So we have to meet both conditions. We're looking for the intersection. So female and social sciences. So there are 14 women in the social sciences out of the 57 in the sample. Remember, the and is your overlap or your intersection. So 14 divided by 57 is 0.24564. 3 decimal places. Third place is a 5. Next door is a 6. It is going to bump it, so it becomes 0.246. The other thing that I would caution you about as you're working through your homework problems on this particular lesson related to probability and contingency tables, Minitab prefer, or not Minitab, but D2L prefers that you enter this leading 0. So notice how I'm writing these: 0.246, 0.174, 0.364. That's the way that D2L is going to prefer that you enter them into the computer. It wants to see basically that leading 0. Questions? All right, one last thing that I want to talk about today, which will kind of get us back on track, okay, and then give us a day, give us an extra day. I'm probably still going to delay Module 2 exam to give you a day to ask questions, okay, is we take this information about probability and how to calculate probabilities, and we create what are called probability distributions. Okay, we create what are called probability distributions. Even this morning, at the beginning, we were talking about frequency distributions. We learned about the categorical frequency distribution of how to organize qualitative categorical data into a table. We also learned how to do that as a grouped frequency distribution for quantitative data. That frequency distribution often becomes our jump start for some of the graphs we create, but it gives us a description of what really happened. What really happened when we rolled the die 20 times, or what really happened when we flipped the coin 50 times. What really happened? What ages did we get when we surveyed the students? What eye colors did we get? Okay, so it shows us the reality of what really happened when we conducted our research and collected the data. The probability distributions that we're going to begin talking about next class describe for us what probably or what should happen based on an assigned probability for the outcome. You know, if I'm flipping a coin 20 times, I know that I should expect to get a head 50% of the time. So I would expect to get 10 heads. Now, is that what happens in reality? Probably not. Okay, so the probability distribution describes what probably should happen based on assigned probability, whether that probability is theoretical or whether it's one we've arrived at by using a contingency table through an experiment, through a survey. It gives us more of a theoretical, more of a theoretical perspective. Okay. Probability distributions can also be presented as a table, as a graph, or even a formula. And sometimes it depends on, again, your audience. What are you trying to do with the information as to whether you're going to use a graph, a table, or a formula. We're going to spend most of our time looking at it from either a table or a graph form. There are two types of probability distributions, and normally in this course we would look at both types. But because this is an 8-week course, I have elected to omit the discussion of the discrete probability distribution and focus our attention on the continuous probability distributions. So you have a discrete probability distribution which has a countable number of possible outcomes. Again, think about our discrete data. We have whole units, so I might be looking at how many times, if I flip a coin 10 times, how many times do I get a head? How many times do I get a tail? I can count that. Those probabilities are often determined theoretically or by observation. Again, we can create either a table or a graph. And the two requirements go back to the two basic rules of probability, that all probabilities are between 0 and 1, and the total of the probabilities has to equal to 1. The continuous probability distributions, which is going to be our primary focus, again, think about quantitative continuous data that's on a measurement scale, and there's no gaps in that scale, so you have an infinite number of possibilities between any two values on that measuring tool. You're on that continuum. These probabilities are usually determined theoretically, not by observation. They can also be shown as a graph or a table. And again, it's locked up on me, so hold that thought. Okay, so the two requirements for the continuous probability are really directly related to the things we learned earlier, that the probability of each outcome is between or equal to 0 and 1. So we still have that condition for the continuous probability distribution. The one that's a little wonky is this idea that it's the sum of the probabilities in the sample space have to total to 1, because we begin thinking about it, instead of thinking about it as a numeric value, we begin thinking about it as the area under the curve or the area under the graph of the distribution. Because typically with a continuous probability distribution, although it can be in a table form, we most times will see it in a graphical form. With discrete, again, it could be either, but again, most times you see it in a table form. And so that's a little bit of a different idea for students to grab a hold of. And we'll talk more about that in our next discussion. There are a variety, a number of discrete probability distributions, and there are a number of continuous probability distributions. Again, I have decided for this 8-week session not to cover the binomial. Normally, we discuss the binomial probability distribution, but I have elected not to do that because of the time constraint. Some other discrete probability distributions are called the Poisson and the hypergeometric. Should you choose to take Stat 2401, which is the course that I'm teaching the next 8 weeks or the second 8 weeks, we do actually spend some time talking about those. For continuous probability distributions, we're going to talk about a variety of them throughout the semester. The most important of those is the normal distribution. And one of the reasons I decided not to talk about the normal, or excuse me, not to talk about the binomial or the Poisson, is that we can use the normal to approximate these others. So the normal is probably one of the most important probability distributions. It's one of the most useful that you see in statistics. And so our attention on Wednesday will be on that normal distribution. Okay, so a couple of things, let me remind you. go back to my share screen for a second. And go back to the announcements we made at the beginning of the class. One is your class participation 6 is now due on Sunday, February the 5th. The Module 2 exam has been delayed. It will not open on Wednesday, February 1st. It's probably going to open on Tuesday, February the 7th. You should also now be able to do lesson 4, I believe it is, or not lesson 4, but the homework on probability. You should now be able to do probability and contingency two-way tables, as well as the descriptive statistics. Okay, so you're ready to start those. We will begin the discussion of the normal distribution on Wednesday. So I have 2 minutes. Do you have questions before we adjourn for the day? Okay, if not, then I will see you ladies on Wednesday and we will discuss the normal distribution.